Hello students, welcome to Edusel. In this video, we are going to discuss about randomized algorithm, one of the application that we are using the randomization in Quicksort. Basically, we know the Quicksort how it was working, and the main problem which we found is in worst case scenario. Where is the worst case scenario is like if the numbers which are being given to us is sorted, then how do we say like whether the element set is sorted or not? To verify that one, again, if you are running the quick sort, it takes n square time complexity, which was like the recurrence relation, you can say, is all about like tn equal to tn minus 1 plus big of n or n, like cost is n. So this, if you have solved it, you are getting with n square as a time complexity, which we have already completed in a quick sort video. Those who are new, kindly watch the quick sort, like how it is working. But in this video, we are not exactly discussing how quick sort is working. We are just discussing those things which are a part of randomized quick sort to reduce this lecture insert. Like we are trying to only focus like how the randomized quicksort is working, how the median finding we are doing using the randomization, that we are going to discuss. Let us start. So in this video, basically I have collected the content from Tado's book. So this is one of the content, like I have followed the book here. So I kept the same content as it is there in the book. Okay, so it's 13.5. It basically we are working for to find out the median. We first working with the median finding. Why it is needed, I'll tell that after just completion of this video. Then you will definitely know how median finding is helpful. But before that, as I told you, like median finding is a key factor here. So median finding is like if you know, like as per the content, suppose 1 2 3 4 is sort of elements given to us. Like as we are working with the worst case scenario, at least we should start with that one. So 1 2 3 4 is a set or number set are providing to us. We have to check which one is the median of it. In general, median is the middle element among all these numbers. This is what is called as median. Median in mathematical term is sensing like we have to find a middle element providing with the number of elements. So how do we find? In general, to find this, the simple method is k is k is a median, okay, which will be found out if n is odd. N means here n is number of digits or number of elements are considered as the uh, n. Okay, next k is, you can say, it's a largest element. Suppose you are finding out which is equivalent to the kth largest number. Here we can say we are trying to find out the largest element out of those elements. Whenever we are trying to find out, we are just following the concept of median finding. So we can say it is we are just saying it is one kind of median for us. Or to check, how do we find, like if n is odd, I'm just writing that one again. If n is odd, like the values are odd, means the number of elements are odd inside it, then what do we have to do? Like k is n plus 1, n plus 1 divided by 2. If n is even, k equal to n by 2. This is what the representation of k value we should have to know. Like whenever we are finding the median of this number, so k represents the median of it. Like how do we find? Like the position, first of all we have to find it out. As per this example, n is 4 here, which is even. For this, k value will be 4 divided by 2, which is 2. K2 means the second position will be the position for k then. Clear? We say for a timing is a position we found out for the median as 2. Whoever the value will be, so that position will be fixed as R. median of the numbers provided. So here one condition we should have to always keep in mind. Suppose it is sorted, then only we can say, here it is written like their median could be found out if the middle position, if we were sort them, means if it is sorted, whatever the value you found, definitely this is called as the median of the set elements provided to us. As per this example, I have just given you the simple example 1 2 3 4. Out of this we found k is 2, means the first position, then this second position, this 2 is a median of this. This is what the answer says. If it is just not sorted, means 4 2 1 2 like this, suppose certain unsorted numbers are provided, then we might find the position, but the position is not correct answer for the median. So that's why we need to sort them. So the problem is, while you are finding the median, if you are sorting that, first you have to sort it, then you have to find the median, then it is not good. By the way, if you are sorting it, for sorting the best time complexity it is taking is, or the worst time, basically best, why I'm saying, because some sorting algorithms are there which are providing us n square. So out of those n square, n log n, or whatever the values we got, so like we can say, it is a time complexity which is helpful for a sorting of numbers. You can say if you are using merge sort, if you are using quick sort, for worst time complexity we are not considering. For average and best I'm just talking about for the quick sort only. But heap sort, n log n, n log n throughout. If you are sorting the numbers, then you are finding the median, it will give you the value as the time complexity as, I'm just writing TC is n log n. But if you are using a randomized algorithm, I'm just saying in short RA, the time complexity could be reduced to big of n instead of saying it as n log n. So randomized algorithm and randomization will helpful for us. It will decrease the time complexity before n log n to n. We are not going to sort anything. We are simply finding the median using select function as per the book. Okay, and we will definitely get the value as, or get the complexity as n big of n, instead of, I'm just again simplifying it here, n log n was there previously to find out the median. And if you are using a randomized algorithm, that will convert to big of n in, uh, like instead of getting it as n log n. So randomized algorithm helps us to reduce the time complexity as it is clearly mentioned in the book. But this paragraph exactly tells us like how we are getting as n. Next, select function, like how we will be expecting the complexity as n, that we are going to discuss. Here a select function is there where s is, you can say, a number of elements. What are the number of elements within a set comprises of number of element. K is, you can say, is a number through which we are trying to find out the median of whether the median existing or not, or a splitter. Basically we can say K helps us to find a splitter for us. Okay, helps to find splitter for us. Splitter in the sense like the number which has been selected, this is the median for us. Clear? Next, choose a splitter. AI, might be it is not visible to you, so you can check in the book, it represents as AI, and this is AJ. Okay, here the condition I am again writing, might be it is not being shown to you. AJ, if it is less than AI, here the condition is AJ if it is greater than AI. Okay, now we will be discussing. First, you can take a random decision. I'm just taking the example here, the sort example I'm taking, only 4 digits that we are going to take. So if S is given to us, which is not being sorted for the timing 4 3 4 2 1 3. Suppose this is our number. So what we have to do, like splitter we are trying to find out in a random. Okay, the AI, suppose I am selecting out of these numbers, or you can say suppose I am selecting 2 as our uh, just a random splitter that I'm doing. Splitter splits into 2 different half. Okay, so next is to find the better, I must write it. K helps to helps helps in finding median, because AI exactly helps us to find the splitter. Okay, so here look, if I am doing this one, so S minus is a set which will have like other elements excluding this AI is considered as AJ. So which are less than this, like less than 2 is only 1 is existing, and plus will consider all the values, all the elements which are greater than 2. Greater than 2 is 3 and 4. So I'm just writing the condition. As per the condition, it is AJ is less than AI. We are just keeping that in our S minus. Here AJ, if it is greater than AI, whichever the AI you have selected is random. This is a random selection. A random selection. Okay, you have done this a random selection. Next, based on that, we have shortlisted this S minus and S plus. These are two different sets. Next target is for this. Okay, we will be discussing the time complexity beside to this one. Next is like if S minus is like, we need to find out the K as n is even number. So you can say n is 1 2 3 4, and for K it is n by 2, 4 by 2, which is 2. K is 2, that we know. Next, S minus if S minus is equivalent to K minus 1, that means like we are getting S minus as like 1, which is like one element is present. So I'm just writing the mod is exactly telling us number of elements. This mod is the number of elements present. So this S minus is helps us to say number of elements that we write here. I'm just writing it, number of elements present in S minus. This is what the modulus exactly tells us. So here S minus only one number is present, like one element is present. K minus 1 means previously it was K is 2, and here it is like we have to deduct that one with a minus 1. So here we found 1 equal to 1, means if condition is getting satisfied. Next, splitter AI was the fact of desired answer, that this means AI is a best splitter we found. This is just for a first time we are getting. If you are checking out with 3 as an answer, definitely you have to run for 2-3 times or one more time. Clear? It depends on the selection, like how you have done the selection. Like for this one, I must tell AI which I have selected is the best one. Like AI which is equal to 2 is the best selector, a splitter. I'm just writing this one is the best splitter because of this condition. If it is not following the condition, we have to find the kth largest again. Then once you should remember a note, I'm just writing here, maybe it is visible to you. Note the number of times you might run. K value won't be changed. This remains for first K value. Why it will not change? Because if you change the K value, you cannot find out which is the best suitable splitter, or you can say a median for the number provided to us. Okay, so you should always remember K value will remain same as it is throughout the, I'm just again reframing this one, but it is, if it is not being understood, k value should k value remain same throughout the algorithm. Okay, it will never change. Once you found it is 2, so you should have to keep it 2 for number of times. If you are running, so you should have to care this way. But in general, the people are doing in a wrong steps. I found many problems. So they, what they are doing, so they change the k value in like as they have shortlisted. Suppose in s, instead of getting 1, suppose I am just using 2, that's why I have this one. So if I would change this through, if I'm taking ai is 3, so here 1 and 2 will be in s minus, and for s plus it will be 4. So within that, as we found 2 is a best splitter, again we have to do this else condition. If you are running the else condition, that time if you are changing the k value, definitely you will be having a problem. So you should keep in mind the k value should not be changed. Now we should go for the complexity. Complexity here, you can say choosing of it is big of 1, here it is big of n, here it is the if else condition. I'm just in general I'm just writing it is of big of 1. So total time complexity we are getting is big of 1 with n, which is our final time complexity. So if you add everything, so definitely you will getting as big of n is the maximum time complexity or worst time complexity for this one. So we are not going to sort anything, but we will be finding those elements, or might be one element which is the best splitter or a median for us. So in this way we are using the randomized algorithm, and we will be definitely getting the correct answer without sorting it. So in this way we are getting the n log n, instead of n log n we are getting as n as a complexity while finding. So best, this is if such type of questions are being asked in your exam, or might be if you are preparing for any competitive exams, if such questions are being asking, so you have to properly analyze this, the algorithm provided. So you have to write each and every steps with the complexity. You have to compare, which I told you earlier, like it was previously, we have to sort it. If you are sorting, so each sorting technique will, the best sorting technique you can say will be giving us n log n, so which is more than n. So we have not to sort every element, but we will be running this algorithm and we will get it as n. Instead of getting is n log n, we are getting it. So such questions could be expected. If such questions will be there, you have to write your answer in this way. Now we will go to the application of this median finding in Quicksort. So previously what we are doing, so previously we know we are having uncertain things also, but we can find it the median value of it. But if I want to find the output should be in a sorted order, then I am just following the Quicksort. We will start it again. So from the beginning, what it has to follow, like if it has 3 elements, so then no need to check anything. You just use the sorting technique as previously being taught to you, like n log n could be the best answer for it if I'm saying the time complexity this side. Next, what it has to do, like the splitter, we have to find a random splitter, as we have done the same example. I'm running it here also. S is a set where we have to again doing the selector there, so which is 4, 2, 1 and 3. So what I have to do, like I'm just selecting the, again 2 is our answer. To get the correct answer, so I'm just taking 2 as a random answer. So next, s minus and s plus. S minus will carry less than this, which is 1 only, and s plus will be like just above to this one, 4 3, or any order you can write. I'm just writing in a correct order, so you change it as per your answer. Okay, this is not always right to like this one. You can change it also 4 3 also, not an issue. But whenever you are doing this, you have done it like choosing. Next, for loop you have run, which takes for loop, like n times you are running. Next, recursively you have called Quicksort. As you have already studied Quicksort, how you have run it, so you just run the Quicksort for both the end. Quicksort, I'm just writing insert Quicksort s minus, then you have to place this ai Next you have to run the quicksort, which is s plus. So once you have done this one, so your output will be like, here I'm just writing the output. So here you are getting s minus is 1, only one element, so no need to worry. Next you have selected 2. Next, if you are running the quicksort, definitely 3 and 4 will be the answer you are expecting. So if you merge this one, you are getting 1 2 3 4 as a solution or a answer. So I told you from the beginning that we are not going to discuss the quickshot again, because if I am teaching this one again, it will be a long video. Expected video should be short, at least, through which at least we should go through the concept. So those who are new how the quickshot is working, you please visit the previous videos there. Okay, next what we have to do, the output as we said is s minus ai, then s plus. Sorted means quick sort. After applying quick sort, we have to use this one, then we have to do with the end if condition. As for the time complexity, if I am saying the time complexity, here I am running with the if condition. Within that we have to use the sorting things. Okay, you can check if it is there, so n log n could be the answer as a time complexity n log n. Next here it is, I'm just adding with big of n because it is running for n time, and this recursive call, it is providing you n log n, means 2 times by the way you are running the quick shot. So I'm just writing plus big of n log n, so it might be big of 2 into big of n log n. Next output, though you are writing it, it is big of 1. So in total you are expecting, if you are adding everything, so the answer will be, the time complexity will be big of n log n base 2. Clear? The worst time complexity we can compromise. How? Next you have the question, as you have, as I have already told you earlier, like we have worst time complexity n square, and we will definitely minimize it using the randomized. That's why a modified quick sort is there. What exactly we have to do in modified? Basically the same as it is there, we have already discussed the same thing. Next the output is sorted list, like if condition it is there, end it. Next, else part, what we have to do, like we have to check whether a splitter is a correct splitter or not. Like based on the best splitter, you can do the work, and the work will definitely help you in this regard. Like once we are doing the selection of previous, like we are selecting the splitter, we are checking with whether it is correct or not, then we are just doing the quick shot and we place that one. Okay, so what exactly tells the same thing added earlier also it gives. The main thing they have added is whether the AI which you have selected is a correct splitter or a best splitter or a central splitter or not. Based on that we are just running it, and the same time complexity I'll be discussing. First I'll be discussing with the example, the previous example. Okay, so it was 4 2 1 3. So as I told you, like the splitter I'm just taking with an example of 2, and for si and s plus, sorry, s minus and s plus, s minus it will be 1 and s plus will be 4 and 3, because as per the starting order I'm just writing, because it is not sorted by the way from the beginning. Next what I have to do, like s minus, whether what I have selected is a best splitter or not. From the beginning we have to check. Earlier there is no such findings that we did. Okay, might be whatever the splitter that you have selected. Luckily I have selected the 2 as our splitter. So if you select anything and you can pick it within this one, like without any centralized one, like to check whether the number is sorted or not. From that, if it is sorted or not, 1 2 3 4, suppose you started with, so if you start with 1, so definitely the s minus is blank. So if you're doing the quick sort in s minus, so it will not giving you any result. So it's 5 simple. So 1 will be added as si, ai is taken as 1, and 3 4 5 will be, or 3 4 whatever it is written, so it will be a quick sort. So the problem is the more it will run, the more time complexity we can expect. But if you'll get a best splitter or central splitter, okay, if it will be in mid, like median, if you will be finding, so definitely equally it will be running for both the end. The quick shot will run for both the end. That's why it needs the modified quick shot we are requiring. Like whether we have selected the good splitter or not, how do we find them? S minus is like this represents the number of elements. So I'm writing it here. S minus is 1 because one element is present. Here I'm just take the modulus of this. There are two different elements are present. Like if I am taking S minus, which is 1, if it is greater than equal to the S by 4, which is 4 elements, like here I'm just writing S modulus is 4, so 4 by 4, 4 by 4 by 4, and means this has to be satisfied. Again, S plus, which is 2, is greater than equal to 4 by 4. If both will true, if this is true and this is true, then we can say AI is best splitter. Whether it is following this condition or not, we will check this one. 1, yes, it is equal to 1, and 2 is definitely greater than 1. So definitely we must tell you, or this content exactly tells us AI is a best splitter. Once or best splitter, better I must tell you, like it's a central splitter. The central splitter is our target. The better splitter we found, definitely we can get the better result with a less time complexity. Once it is, it follows the condition, definitely we will do as we have done earlier. For this, the time complexity, again, if you're finding for sorting, this one is n log n, and next for loop is running, so I'm just saying it is big of n. Here if condition, so big of 1, and the recursive, it follows the recursive one. So for this, 2 times it is running, so I'm just writing 2 into, which is c is constant, 2 into n log n base 2. I have to write this. Next output is big of 1. So if you add everything, so you can expect the time complexity would be, here I'm just writing, the time complexity would be big of n log n base 2. I hope from the example you have understood. From the same example, by the way, I have taken to give you the proper idea like how quicksort is working. Before that, how median finding is correct for us without sorting it, but we can give you the best median out of the set or the element set. I hope it is clearly understood by you, but you should remember the log base 2 we are taking. Okay, so if is there any doubt, you please comment below, and thank you. Have a good day.